Hi, this video will be looking at the uses of electromagnetic waves. So here we have the electromagnetic spectrum. Gamma rays have the shortest wavelength and the highest frequency, and then as we move along the electromagnetic spectrum, the wavelength increases and the frequency decreases. We're going to start by looking at the uses for radio waves. Radio waves have the longest wavelength out of all the wavelengths that we look at. Radio waves can be split up into many different categories. We are going to be looking at very short radio waves, and long radio waves. Very short radio waves are used in TV remotes and FM radios. These have a length of around 10 centimeters to 10 meters. To get reception, you must have direct sight of the transmitter, as the small radio waves cannot bend around hills. The next category of radio waves is shortwave radio. Shortwave radio signal can be received at long distances from the transmitter. This is because they are reflected from the ionosphere. The ionosphere is an electrical charged layer of the Earth's upper atmosphere. The final type we'll be looking at is long-wave radio waves. These can transmit information from the UK to the other side of the world because the radio waves bend and diffract around the Earth's surface. Long-wave radio waves have wavelengths between 1 km and 10 km. They are also able to go inside tunnels. We are now going to have a look at the uses of microwaves. Microwaves have a shorter wavelength compared to radio waves, and this means that they have a higher frequency as well. Microwaves are used in communication from satellites, mobile phones, and satellite TVs. They are used because the waves need to be able to pass through the Earth's watery atmosphere, which is the clouds and water vapour in the atmosphere. Satellite TV works by a transmitter transmitting the signal into space where it is received by a receiver dish on a satellite. The satellite then transmits the signal back to Earth in a different direction where it is received by a satellite dish on the ground, such as the satellite dish that is on the side of your house. Mobile phones also use microwaves. In order to save power and remain small, mobile phones send a message over a short range to the nearest mobile phone mast. Some people believe that some of the waves that are sent out by a mobile phone are absorbed by water molecules in some of your cells. The microwaves then heat up the water in your cells, and this may pose a health risk. The risk to your health would be greater if you talk on a mobile phone a lot or if you live near a mobile phone mast. However, there is no conclusive data that points to either of these stories being true. The next type of electromagnetic waves are infrared rays. Infrared waves are used in remotes, communication, night vision, and heaters. Remotes use different patterns of infrared waves to send different instructions to a device. The change channel infrared frequency would be different to the increased volume infrared frequency, and this allows the TV to understand what command it is that you are asking it to do. Night vision works by looking at the amount of infrared radiation given out by objects. The night vision camera would then turn infrared waves into a picture. Items that give out more infrared radiation will tend to be hotter and may be something of interest. For example, if we were looking in a forest and looking for animals, we could use a night vision camera to see if there are any animals about and to get a clear picture of the animal. We're now going to move on to visible light. Visible light is the only part of the electromagnetic spectrum that we can see. Visible light and infrared waves are used in optical fibres. An optical fibre is a thin rod of high quality glass. Light goes into the glass at one end and it undergoes repeated total internal reflection, even when the fibre optic is bent. The light in the fibre optic never leaves the glass and is constantly reflected. Fibre optic cables are able to carry more information than ordinary cables of the same thickness. Also, they are able to maintain the high quality of signal over very long distances. Cameras also use visible light. A lens is used to focus on visible light. We then control the amount of light that is let into the camera by changing the aperture, which is the size of the hole, and the shutter speed, which is the amount of time that the lens is open for. A film is then exposed to light, and after development a picture is revealed. The following electromagnetic waves are not needed for the exam, but I think that it is nice to have some knowledge as to what each of these wave types do. Ultraviolet light is used in fluorescent lamps. X-rays are used in medical equipment to see internal structures of body parts. Some parts of the body absorbs the X-rays waves, e.g. bones, and other parts let the waves pass through. This allows doctors and nurses to see bone structures and allows them to check if they are all okay. The final type of electromagnetic waves is gamma rays, and these are used to sterilize food and hospital equipment. For more videos, content, quizzes and past papers, go on to www.elevise.co.uk.